These days, a growing number of architects, engineers, and contractors are using BIM. And here's why. Global trends are making AEC projects more complex, while advances in technology are helping industry professionals work more efficiently and effectively. This is where BIM comes in. BIM is an intelligent, model-based process that connects AEC professionals so they can more efficiently design, build, and operate buildings and infrastructure through BIM, or Building Information Modeling. With BIM, designers create digital 3D models that include data associated with physical and functional characteristics. The power of BIM is how it allows architects, engineers, and contractors to collaborate on coordinated models, giving everyone better insight into how their work fits into the overall project, ultimately helping them to work more efficiently. The data in a model defines the design elements and establishes behavior and relationships between model components. So when an element in a model is changed, every view is updated, with the new change appearing in section, elevation, and sheet views. You can use the information in the model to improve your design before it's built. Gain faster buy-in and approvals with realistic visualizations. Convey design intent to the field. And, most importantly, retain model intelligence from concept to construction. BIM provides insight into a design's constructability, improving the efficiency and effectiveness of the construction phase, and also providing a better understanding of the building's future operations and maintenance. Owners can use BIM for predictive maintenance, asset tracking, and facilities management, and for future renovation or deconstruction projects. When you work with BIM, you'll experience reduced project risk, improved timelines and cost savings, and better project outcomes. And the power of BIM is growing with cloud-connected technologies that let project teams design and work together in all new ways. Driven by global trends, the AEC industry is in a time of transformation. Businesses that want to win more work, deliver projects more efficiently, and design better buildings need a powerful solution. And that solution is BIM.
What's the technology behind many of the iconic architectural structures being built today? It's a process called Building Information Modeling. BIM is a 3D modeling process that is changing the way people plan, design, construct, and operate buildings and infrastructure around the globe. As early as the 1960s, computer pioneers realized the demand for flexible digital building models. The breakthrough came in 1963 when Ivan Sutherland developed Sketchpad. This rudimentary application allowed users to define geometry and manipulate objects in space with only the help of an electronic stylus on a computer screen. However, these early predecessors built models without data on functional performance characteristics, meaning that without the information on how buildings worked, they were rather superficial implementations. In 1984, these BIM forerunners became available for use on personal computers. But it wasn't until 1986, when Robert H. coined the phrase building modeling, that early programs were first used on large and complex projects, such as the renovation of a Heathrow Airport terminal. In 1993, the Lawrence Berkeley National Lab's development of Building Design Advisor paved the way for systems providing performance data on how buildings and their components function. By the late 1990s and early 2000s, the contemporary outline of BIM had started to crystallize. Objects and shapes had fully embedded metadata and were able to understand their relationship with each other and the building as a whole. 2004 was a huge year for BIM. For the first time, designers, builders, engineers, and owners could all work collaboratively on one centralized, dynamically updated model. For example, if a designer made a change to the model, the project's construction shopping list automatically changed too, such as the number and size of windows. 2008. 4 years later, Parametric modeling also took a step forward with an avalanche of design outputs, giving users even greater control over their project decisions. Meanwhile, laser scanning and reality capture filled BIM models with precise, abundant data, saving time in project preparations, and clash detection made it possible to automatically locate on-site clashes, such as ductwork running through beams, and prevent expensive change orders. With help from clash detection, engineers for the China Zun Tower in Beijing caught thousands of issues in the BIM model. It reduced passive change orders by 80% compared to other similar projects. The indisputable efficiencies in time, material, and cost driven by BIM meant that in 2016, the UK became the leader in legally mandating that all public-funded building projects must use BIM. And other countries are soon following suit. By 2020, Germany is mandating BIM for all transportation projects. With BIM now in the cloud, teams can collaborate on the same model from all over the world, providing great efficiencies. In the near future, BIM and GIS data will merge into one model, helping designers make crucial decisions based on the precise geographic location. As 3D modeling technology advances and is more commercially accessible, the BIM process is becoming more and more integrated with building the wider world, promising a richer, more collaborative experience for users designing and building the spaces we live and work in.